Hello everyone, how are you? I hope you are doing well. So welcome all in this new video. In this video, we will do some EDA and then we'll create a machine learning model using Flight Fare Prediction Dataset that is available on Kaggle. So let's start in the video. So for that, I will open my Jupyter notebook. So I already have opened my Jupyter notebook. I will show you this notebook and the data where I have stored. So these are my data which I will import in the notebook. So this is my notebook which I have already created for you. I will open this notebook file. You can see. So I have given the flight price prediction. This is my heading. Then you can see the work we will do in this notebook. So we will see these things in this notebook. So first is problem statement, then importing libraries, loading dataset, then data inspections, then EDA, then feature engineering. After that, checking for null values, then hard encoding, then feature selection, then creating machine learning models, then hyperparameter tuning, then conclusion. So coming to the first one, that is problem statement. So I have built a machine learning model that predicts flight ticket prices based on the various independent features using a dataset of flight ticket prices from this Kaggle website. So I have given this link of this dataset, so you can check out that dataset. So the dataset includes prices for various airlines and cities between March and June of 2019. So with a training set of 10,683 records and a test set of 2,671 records. And the data prediction result can be beneficial for both travelers who can use it to make informed decision about their travel, and also for the airlines who can use it to forecast competitors' rate and adjust their pricing strategies to maximize revenue with the remaining competitors. So this is about the problem statement. As I already told you, this is the size of training set and this is the size of test set. So training set has 10,683 records, whereas test set has 2,671 records. So the first part is done here. The second is importing libraries. So these are the necessary libraries for this whole book. So we will import this necessary libraries. In the future, if we need some other libraries to import, we will import there only. So I will run this cell using Shift plus Enter. So it will run my first cell, and it has successfully run. Then the second is loading the flight fare data. So as I already have shown you that this is the path where I have stored my data. So the data is under this data underscore data train.xls. So this is my directory. So I have not given the whole directory because I have saved this notebook in the same directory as I have saved in this dataset. So I don't need to give the whole directory name. So I have given a simple shortest library path of this dataset. So I have loaded both the datasets, that is train and test. So I have read this Excel file using pd.readexl, and then again I have printed the shape of that dataset. So as you can see, there are 11 columns and 10,683 rows. So the same for this test data. So it has 10 columns and 2,671 rows. So this is basically, you can see like there is one column less in this test data. That is because this test data does not have this price column. I will show you later here. So if I print the top five rows of this concatenated data frame, that is train data plus test data. So I will show you. So this is it looks like. So you can see there is one price column also, that is price, but this price column show you some values in this train data only. If you print the below values of this flight df data frame, so I will write here tail. So you can see there are no values for this price column, as you already know that basically test df does not have any price values. So this is why it is showing none. So this is what you can understood from here. Then we will do some data inspections. So we will see this data flight df dot save. So this will basically add those rows and column from this train and test dataset. So no issue till now. We will describe it. So as you know, like this describe function only includes our numerical values. So this is what you can basically understood from here, since this data set has only one numerical column, describe will display summary statics only for this price column. So you can see this summary statics for this price column from here. So maximum is 79,512 rupees and the minimum is 1,759 rupees for this price column. So this is what you can understand from here. So we'll do some info and we will check some information about this flight data frame. So as you can see, all these, there are no null values for these columns. Inspect this price column, because you know there is some null values in this price column, that is price values from this test data set. So this is already understood, and you can see the data type of those columns. So that the columns, all the columns are in object data type, but this price column has this float data type. So we will basically check again in the last while doing splitting in X and Y for the model training, but for now this is okay, no problem. Then again this data type we will write. So you can see this data type you will see here also. So it's the same thing, no issue. Then we will do some EDA, and for the EDA you can see like bar chart showing top 10 most preferred airlines. So we will basically plot the graph for this top 10 most preferred airlines. So we'll run this this code, this whole cell, but before that I will basically try to make you understood this whole code. So this is the main code, which is sns.count plot, which will print our draw our graph. So in the X values we have given airline column as input, and the data is flight DF, and the order is basically we will count this airline values. So the airline, that is the categorical variable. So if it has basically it will count all the values for this different categories of this airline. So it will then plot this graph in the after we run this cell. So we will quickly run this cell, and then you will understand more. So this line, what it is doing, so it is basically counting all the total number of values for different type of airline. So you can see Jet Airways has maximum count, and then Indigo, then Air India. So inside is like most preferred airline is Jet Airways, and from all the total flight tickets sold, Jet Airways has the highest share, followed by Indigo. So you can see this from here, so Air Indigo, then followed by Air India, then multiple carriers. So this is what we get from here. So this was the main basically code from this whole cell, but these things are also necessary to make you understand this graph more quickly. So this is what we get from this first graph. So now we will plot graph between airlines and their flight ticket price. So we will plot graph between these two. So this is the code. So first line of this cell, that is airlines is equal flight underscore df dot group by airline, then price, then dot max. So basically this line is grouping by airline feature, then doing this price dot max to calculate the maximum price for all those airlines. So for all those different airlines, so that value will go into this airline variable. Then again, using this airlines variable, we are getting a data frame that is basically doing nothing but sorting values of price in descending order, because here ascending is equal to false. Then again we are printing that airlines data frame. So this is what we were doing. So as you can see, the maximum price for this Jet Airways business airline is 79,512. Similarly for Jet Airways it is 54,826, and then multiple carriers it is this. Then the list is for Air Asia, that is 13,774. So this is what we were doing in this first basically in this upper column. So it is taking the maximum values from all those airlines, so from all those prices of all these airlines. So this is what it was doing. So we will print the same thing here in this below cell. So we will print here. So as you can see, Jet Airways has the maximum values, then Jet Airways business has the maximum values, then Jet Airways, then multiple carriers, then Air India. So the list is Air Asia, and then second list is this multiple carriers premium economy. So this is what we get from here. So inside is like, so basically Jet Airways business tickets are most expensive ones. So this is what we get from this basically upper cells. So then again, price on weekend versus price on weekdays. So we will plot graph for this also. So first what we will do, we will copy this airline and the date of journey and then price in the new data frame, that is days underscore df. So we will print this data frame also. You can see there are only 3 columns, and the next cell what we are doing, we are basically converting this data of journey column in a single in a format of DMY. So it will basically convert to date time. Then again we are basically converting data of journey to day name. So for that we are creating a new column, that is weekday, and then again using that weekday column we are doing this we are predicting that if the date of journey is weekend or not. So for weekend we will apply this lambda function. If day is 1, so day is equal to 1. If day is equal to Sunday, else 0. So basically if day is equal to Sunday, then it is weekend, then the weekend value will be 1, otherwise it will be 0. So this is what we are doing. Then we will basically print this days df dot head, and you can see this is Sunday, so it is showing is 1. Then this is Sunday, then again showing 1, this Sunday again showing 1, but for Wednesday and Friday it is showing 0. So this is what it does. Then again we will print this graph also. So it is taking a little bit time, but you can see like for 0 it is blue, and then for orange it is 1. So you can see orange is always higher than this blue one, except these two, but most of the time the orange is basically higher than the blue one. So blue one means weekday and orange means weekend. So prices of the flights on weekend are higher than this weekdays. So this is what we get from here. So price of tickets is higher on weekend. So this is the insight from this above basically plots. So now the next thing is feature engineering. We will do some feature engineering here. So for feature engineering, so exact day, month, year from date of journey feature and store them in new column. So first we will basically extract the exact day, month and year from the date of journey feature. So for that we will basically use this string.split function here. So date of journey is having basically 3 different string. So we will basically first split them using this slice function. So as you can see here, this date of journey is having this slice one. So we will split using slice. So the first one that will come here, that is journey date. So journey date means this one, so 24, and then this is our journey date, then this is our journey month, this is our journey year. So journey date, journey month, journey year, so everything is same except this 1 2 0 1 2. So 0 tells like the first one which comes after splitting, the one tells like the second one which comes after splitting, this 2 means the third one which comes after splitting of what? Splitting this date of journey column. So this is what it is doing here. So I will run this cell, and then again I will basically show you the top 5 rows of this flight df. So as you can see here, so journey date, journey month, journey year, so these are now splits from this date of journey column. So one thing you can notice, like as I already told you, that all the basically flights are basically recorded in this 2019 year also only. So we know that this 2019 is same for all these rows. So one thing we can do, that we can drop this 2019 column, and then again date of journey column is no longer required here, so we can drop this also. So we will write this code, flight df drop date of journey x is equal to 1, then this will drop this date of journey column, then we will do this journey year value count, so that is 2019 only. So you can see there is only one value of this for this journey year. So this is basically what I was saying here, like this all the records are from this 2019 year only, so we can drop this column also. So now we will drop this column, then again we will print this flight df dot head. We will basically see here there is no journey year column and no this date of journey column. So this is what it means. Then we will see this total stop column. So total stop column, you can see I run this code, but I wanted to show you, I wanted to basically make you understand this code, but no problem. So we want to make this total stop column in numerical values. So total stop, basically if there is non-stop then it should be 0. If there is 2 stops then it should be 2 only. If there is 1 stop it should be 1 only, and if there is 4 stops then there it should be 4 only. So I want to remove this stop and this basically string thing from this total stop column. For that we will split this total stop, sorry, basically we will split this total stop column using this space. So as you can see, there is a space between 1 and stop, 2 and stops. So we will use this space to split this our total stop column, and then we will take the first one, that is 1, 2 here, and then in the next maybe 4, 5 also. So we will take the first one, which is basically value we want. So then again the next code, that is this. So this code is doing like wherever you get non-stops, you just replace with 0. So there is no need to do this split thing in this non-stop values. So this is what this code is doing. So then again you can see 0 for this non-stop, 2 for this 2 stops, and then 1 for this 1 stop. So this is what you can get from here. So again, extracting hours and minutes from arrival time, so and departure time. So on this time you can see arrival time is this, and arrival time is this, and then departure time is this. So what we are doing, basically we are extracting hours and minutes from these two columns. So first I will make you understand this one. So as you can see in this arrival time, so we have this basically March, June, basically this month also. So we can basically ignore all these month values, because we don't need to check this month here. We just need to check this the time of this arrival and this departure. So for that we will first split this arrival time using this space, because we know there is space between time and this month. So we will basically we will split this using this space. So then we will take the first one. First one means this 0, 1, 1, 0 for this first row, and this 0, 4, 2, 5 for this for the third one. And here there is no month, so it will automatically give us this 13 column 15. So there is no need to do this basically this split thing. Then second line, it is basically extracting the hours and minutes from this arrival time. So we will split this arrival time using this column. So basically we will use this column here to split, and we'll take this first one, that is 20, that is basically 0 and 1, 0, 1 as hours, then 22 for this minute. So the first row, which is having arrival time 0, 1, 10. So 0, 1 will go in hours, and then 10 will go in minutes. So arrival hour will be 1, and arrival minute will be 10. So this is what these two codes are doing here. Then again we will draw this arrival time column, because we don't need now here. The same thing we are doing this departure time. So we will basically splitting this departure time using this column, then taking first one as departure hour, then they're taking second one as departure minute. So we are doing as type as in, because we know that these are the integer values. So we will do this as type in. So no need to explain that thing here. So again we will basically draw this. We will print this top 5 rows. So as you can see, there is no basically arrival time and departure time column, instead of those we are having arrival hour, arrival minute, and departure hour, departure minute. So this is what we are talking about. We were doing this in this cell. So I have explained a lot here, but I hope you have understood this. So the root column tells about the journey's path. The root column can be removed because total stops field has already captured this value, and both are related. So we will basically drop this root column. The additional info column can be dropped since more than 70% of them have no information. So you can see there are no information for this additional info. So we will drop this column also. So we'll run this code and we'll drop this basically root and additional info column. So duration column, so exact hours and minute from duration feature. So extract hours and minutes from duration feature, convert hours to minutes and find total duration in minutes to make it a single column. Basically this is what we will do in this below cell. So for that, first thing we will do here, first we will basically as you can see here, duration hour, that is duration here. So duration here you can see that is 2 hours 50 minutes. So it has two things. There is first one is 2 hours and then 50 minutes. So it has two things, hours and minute. And again hours means it is having h after 2, and then minutes it is having m after 50. So we will consider all those things carefully. So for this for first we will split this 2 hour 50 minutes in hour and minutes only. So for this we will run this cell. We will basically split by a space, which you can see here. There is space between hours and minute. So we will split by a space, and first one that is that we can extract using 0. So it will go into duration HR. Then second will go in duration minute. So this is what we are doing here. I have in the first cell, and again second cell. So you can see there is a new column duration HR, and we have extracted the hours column, hours values from this duration column. Then second code we will run, and second thing you can see here, we have extracted the minute values from this basically duration column. So there you can see there is none values for this third row, because it does not have any basically minute column here, minute here. It is having only 19 hours, so it will give some basically none values here also. So we will fill all those none values using 0. So we will use this dot fill NA. So we will use this fill NA on this duration minute column. So it will basically replace all those null values with 0. So the next thing is that we will check like there is some h in this duration HR column, or there is some m in this duration HR column. Basically we will just try to check all those values, although for all those values of this duration HR and duration minute, if there is having some HM in those all or not. Basically we'll show you here. So there is no values in duration HR which is having h. So all the values are in this int format only. So the second is duration HR is having m or not. So you can see there are two values which are having m in their duration HR. So we will see it later, but first check for all the four. So you can see there is no h in this duration minute column. So there is no m in this duration minute column. So there is only one thing you can basically do here. This is duration HR which is having m in their column. So we will see which are those values. So we will write this basically code for this to check out which are those two rows having m in their duration HR column. So these are the two rows which are having m in their duration HR column. So duration HR column, which you can see there are 5 minutes. So this should not be here. It should go into this duration minute column, and here it should be 0. So basically what I will do, I will copy this duration HR, these two duration HR values in duration minute column. Then I will replace this duration HR values for these two columns with 0. Then I will try to basically make this I will try to remove this m from this 5m. Basically we want only integer values, so we will replace this m with we will replace this 5m with 1 only. So this is what it is doing here, duration HR values from these two columns into this duration minute column. So this code will copy from this duration HR column to duration minute column. So all the values from these two rows will copy into the same row but the different column. So that is duration minute column. This is what this code is doing. And then next code, that is we are basically replacing 5pm with 5 only. So this flight df duration minute. So all the values which are having 5pm in the duration minute column will be replaced by only 5. So this is what this code is doing. So now we can see, like as you can see, there is no m here. Once again I will basically replace this duration HR M, that is this column. So duration HR column, duration HR row, which are having 5M, will be replaced by 0. So we will replace all those two columns which are having 5M in their duration HR will be replaced by 0. So we will replace it by 0. Now we will check again if there is basically M values in this duration HR. So there is no M values in this duration HR column. So again we will check. So you can see there are these two rows have gone now. There are no rows which are containing M in their duration HR column. So one thing you can notice, like duration HR and duration minute are integer values, so we will change their data type. So we will do this hash type in and we'll change the data type. So now the final thing, like we have to make a single column, that is duration, and what we will do here, we will basically add these two things which we just convert hours to minutes and find total duration in minutes to make it a single column. So we will do this, we'll perform this thing here in this basically 44th cell. So for that we will basically change this hours into minutes. So we will multiply by 60, then we will add this duration column. So we will create a new column, that is duration. So after that we will drop this duration HR and duration minute column, then print this flight data frame. So you can see there is no duration HR, duration minute, except that instead of that we have a new column, that is duration. So this is what it is doing. So these three lines are doing this. So for the sanity check, we will check if we are having, so as you can see, like one of the rows from where we were doing all this stuff was 6,474. So the name number was this 6,474. So yes, you can see the duration is 5 minutes only. So this means we just made this dataset more useful. That was basically that was going wrong if we do not change here. So I think now we will check some null values, if there are some null values. So yes, there are some null values in this price dataset, sorry, in this price column, and that is from this test dataset only. As I have already told you that price dataset does not have this, this test dataset does not have this price column, so there will be some null values for this price dataset. So this is what it means here. And then one more thing you can notice, there is one missing values in this total stops. So for filling those values, so basically for this price column we will fill this price column with their mean. So I already have basically taken the mean of this price column and then fill that null values with that mean. And the same thing, first we will check basically value count for this total stop. So there are total 5 types of basically two stops here. So you can see most of the stops are in first one. So the one is most frequently occurring value, so we will fill its total stop column null values by 1. So we will fill this by 1 only. So we will fill that by 1 only. One more thing you will notice, this total stop is a object data type, so we will basically change it to int also, because it is a integer value, it is having an integer value. So we will basically run this cell, that is dot fill na by 1, then we will write this cell and we will basically change the data type of this total stop column. So I will run these two cells, then again we will check if there is any null values or not. So there is no null values, so let's move on. Now we have come to this encoding part. So we will basically do some level encoding on this categorical data and convert it into numerical data. So we will use level encoder here. We will import level encoder from sklearn.preprocessing. Then we will call this level encoder as LA. Then basically we will do fit and transform all these three features, that is airline and source and destination. So for that we will run a for loop, and then again we will basically print this top 5 rows of this flight underscore df column, flight underscore df data frame. So this is what this code is doing. So it will change this categorical values in the numerical values. So as you can see, there is no categorical values in this airline and source and destination. So now you can see in this column where airline, source and destination were having some object data or categorical data. Now they are having some integer data, so numerical data. So this is what it was. It does this level encoder. Now we will do this feature selection part, finding out the best feature which will contribute and have good relation with the target variable, that is price. So let's use heatmap to find correlation between feature. So we will basically print this sns.heatmap using this sns.heatmap function of this cbound library. So as you can see here, I have taken the correlation, that is flightdf.correlation. This is a function which will give this correlation of this all these values of this data frame, that is flight underscore df. So it will give me the correlation between all the features. So then we will print this. So we will run this cell and we will print here. As you can see, so this is our heat map. So summary of this heat map is price and total stops are highly correlated. Price and flight durations are highly correlated. Duration and total stops are highly correlated. So you can see here price, total stop, price, flight duration. So this is price, then total stop. So price, then total stop. So this is flight. So price and total stops are highly correlated, plus price and duration are highly correlated, and then duration and total stop. So duration and total stop. So this is total stop, and then this is duration. These are highly correlated. So this is what we can understand from here. Then now we will build machine learning model. So for predicting the price, we will build 3 models using following algorithm. So first one is k-neighbors regressor, second is decision tree regressor, the third one is random forest regressor. So compare the accuracies got from these models and select the best model. So after apply hyperparameter tuning to increase its efficiency. So this is what we will do in this upcoming cells. As you can see, we already know that total 10,683 rows are in this basically where in the train data set, and the rest were from this test data set. So we will split all those train and test data set which we had basically imported in the first cell. So now we will split all those values. So as you can see this now first I will run this cell, then again this cell. So as you can see, this train data set which was having price column, so it is having some price here, but the test data set, so it is having price value same for all the rows because it is replaced by the mean values of this price column. So we will not use this test data frame for our model creation. We will use this train data frame only. So we will basically split data into x and y. So we will write these two graphs, these two code, and it will split into x and y. Now we will basically split data into train data and test data. So we will use x and y for this training and testing data. So our test size is 0.25 and random state is 0. So if you want same output as of mine, then you can have these two values same as of mine. So now we will import the models. Now we will run this cell and import these models, and I have imported this RT score and mean absolute error and mean squared error also, which we will use for testing the score of these models. So this is what these cells are doing, and then we will write function to train the model. So we have created a predict function which will train our model. So as you can see, the first one is like this. We have taken the name of model as algorithm. So algorithm.fit. So it will fit on x train and y train data. Then it will predict. That will go in y predict, and then we will basically we will check the score of this model on this y test and y predict data. Then we will check this mean absolute error and mean squared error. Then we will only return this R2 values, that is R2 score. So now we will run this cell and we will basically use this KNN function, KNN model, to predict this all these things. So we will call this KNN model on this predict function. So we will call this predict model, and we'll give algorithm as KNN. We will give KNN k neighbors regressor as algorithm. So the output will go into KNN. So this is what this means here. So algorithm is k neighbors regressor, and the predicted values are these, and the R2 score is this much, mean absolute error is this much, and mean squared error is this much. So the same thing we will do with the decision tree regressor also. We will give decision tree regressor as algorithm as input, and in this predict function, and will show us the results here. So the predictor values are these, and the R2 score is this, and MA is this much, mean squared error is this much, and the algorithm was decision tree regressor. So R2 score is 0.60, and for the k neighbors regressor, the R2 score is 0.58. And then again we will do this for random forest regressor also. So as you can see, the algorithm is random forest regressor, and the predicted values are these. So these are the predicted values, and the R2 score is 0.80, and mean absolute error is this much, and mean squared error is this much. So as you can see, R2 score is better in this random forest regressor compared to decision tree regressor and k neighbors regressor. So further you can see accuracy is much better in this random forest. So we will use this random forest model, so because it is most accurate one. So we will do this hyperparameter tuning on this random forest model only. So we will do this hyperparameter tuning on this random forest. So for that we will import this randomized RGB. So as you can notice that we have a large data set that is having 10,000 plus rows. So we will use this randomized search-CV. If it was having less rows, then we could have used grid search-CV also. So we will basically use this randomized search-CV here. So for randomized search-CV, these are the basically parameters which we will use. So the number of estimators are 10, 120, 150 till 250. Then max features are auto square root, and then max depth is 5, 10, 15, 20. Then minimum samples split are 2, 5, 10, 1500, and then minimum samples leaf are 1, 2, 5, 10. So this is basically parameters for this random forest regressor for randomized search-CV. So as you can see, I have called this randomized forest regressor as RF regressor. Then we will give input. We will give this RF regressor as input in this basically randomized search-CV. So the estimator will be our RF regressor. So and the parameter distributions will be random search. So that is what we have named here. We could give some other name also, but we have given the name random search only. So parameter distribution will be random search, and our cross validation basically will be having three folds. So we will have 3k folds here. Then number of jobs is -1. Then this is by default basically. So these are basically the things which doesn't matter. So random state is 0. So these are the things which we do in this random forest search regressor if we are using it is with the randomized search-CV. So these things we can explore much more. So it is not like I have come to this these values in the first trial only. You can basically play with these estimators and then come up with the basically the right values which gives you most accurate model. So this is what I have given here, but you can change here, you can do some changes here, so it is up to you, but I have given these values as these only. So now we will fit this RF model on X-train and Y-train. So all those things will go into RF model, then we will fit this RF model on X-train and Y-train data. So this cell basically will take some time because it is having so much combinations to try and give us the result. So as you can see, then n estimator is having total 7 values, then max feature is having 2, then it is having 4, then next is having 5, then the max sample leaves is having total 4 values. So it will try out all the combinations using all these parameters, then it will give us the right parameters which will give us the best accurate model. So as you can see, this cell have run successfully. Now one more thing you can see here, like we can print the best parameters among those which we have given here. So we will see what are those parameters. So an estimator is 200, so and minimum sample splits is 2, so minimum sample leaves is 2, then max feature is auto, and the max depth is 15. So this is the basically these are the estimators which are giving us the best accurate model. So this is what it does, this randomized search CV does. So now we will use this basically RF model to predict values on the X test. So we will name predicted values as spread, and now we will check the R2 score. So the R2 score is 0.8237. So basically after hypertuning, the accuracy increases. So for random forest regressor before hypertuning, R2 score was 80%. After hypertuning, R2 score gone to 82%. So value of MAE drops as well, indicating that we are successful in the tuning of our model. So this is what this hypertuning does after we do here. That's what we did here. So basically this is how you use this, you do some basically model creation. So I think we have come to the end. The conclusion is like we have used random forest regression for training the model and improved its accuracy by doing hyperparameter tuning. As a result, we have trained our random forest model to forecast fare of flight tickets with an R2 score of 82% basically. So this is what it means. So this was all about this flight price prediction. So I think you guys have understood. If there is any problem, then please do comment in the comment section. I will reply as soon as possible. So thank you, and please do subscribe my YouTube channel. I really hope that I could help you. I can help you in any possible way. So thank you for sticking till this end, and bye bye.